Hi everyone. So we're going to look at another application problem. I know related rates are a little difficult sometimes, so it's better to see all different types of applications. And so let's just get started. It says Mr. Brust is using a ladder to paint his house. The 17-foot ladder is leaning against the house when Kelly decides to pull the base of the ladder away. Ooh, that's not nice. From the house at a rate of 3 feet per second. How fast is the top of the ladder moving down the side of the house when it is 8 feet above the ground? Alright, so there's a few things that's going on here. So the first thing is they are telling us that the ladder itself is 17 feet long and it's leaning against the house. So this right here is 17. That is where the ladder is facing. And we're looking for, let's see, he's pulling the ladder away from the house at a rate of 3 feet per second. So he's pulling it this way. I don't know that distance, but I know that is the rate. So I guess we're going to call this, let's call this x, because I don't know that distance. But I do know that the rate of it, so dx dt, is 3 feet per second. Then it says, how fast is the top of the ladder moving down the side of the house? Alright, so we're moving down this way. That's a vertical, so let's just call that y, since that's what we're kind of used to. So we're looking for how fast it's moving down the side of the house when it is 8 feet above the ground. Alright, so we're looking for the rates, so we don't know how fast it's moving down the side of the house, so we don't know dy dt. That is what we're looking for. But we do know, or we want to look for it when it is 8 feet above the ground. So we want to know what that is when y is 8. Okay, so, well, let's see here. So the first thing I notice is that this right here is a right triangle, which means the relationship between the three sides is done by the Pythagorean theorem. So I know there's this relationship going on here, and usually we say R or whatever, but I guess we'll say Z in this case. So let's see, when y is 8, we want to know dy dt. Well, if you notice, we also have dx dt here, so we're going to need to know what x is. And so let's just find x. If we know that, for instance, y is 8, and actually we know z, because z is 17, that's the length of the ladder, and that actually is never going to change, right? The length of the ladder is always going to be 17 feet. So what I'm going to do is I'm going to plug in, so I don't know x squared, but I do know that y is 8, and the length of the ladder z is 17. So we have x squared equals 6, oops, not equals, plus 64 is equal to 289, and I get x squared is equal to, what is that, 225. So x, if I take the square root, is 15. Alright, so we know those. Alright, so we know all that stuff. Now what we want to do is find that dy dt. Well, like I said, we already know this relationship among the three sides. So let's just kind of continue with that. Let's see. So we have x squared plus y squared equals, and in this case it's really 17 squared. We can just plug in the 17 since the length of the ladder doesn't change. And let's differentiate that. So I am going to differentiate with respect to time. So I have 2x dx dt plus 2y dy dt. And actually, since this is a constant, 17 squared is 289, if I take the derivative of that, that just equals 0. So that worked out nicely for us. Alright, so we want to substitute what we know. So let's go back here. What do we know? We know dx dt is 3. We know x and y, so we're looking for dy dt. So we have 2 times our x, which we said was 15, times our dx dt, which was 3, plus 2 times our y, which is 8. And remember, I don't know dy dt, but that's what I'm going to be looking for. And that equals 0. So let's simplify a little bit further here. And let's see, 2 times 15 times 3, what is that, 90? Plus 16 dy dt equals 0. So remember, we're trying to get this. So let's see, 16 dy dt is equal to negative 90. And if I divide by 16, I get dy dt is equal to, what is that, negative 5.625. Alright, so if you're wondering why it's negative, it should be, right, because as you're pulling the ladder away, if you remember, we're going down, right, so the direction. We can say that the ladder is moving down the side of the house at a rate of 5.625 feet per second. So when we write our answer, you don't usually have the negative because when we're saying that's moving down the side, that's indicating a negative direction. But just so you know, that's why you see the negative there. So there we go, 5.625 feet per second is how quickly, or the rate at which the ladder is moving down the side of the house.